This is Knowledge Engineering with Semantic Web Technologies. This is lecture number 6, Knowledge Engineering. And we start the Knowledge Engineering lecture first with the data we are going to work with. And this is so-called linked data. What is linked data? So this question we will cover in this part of the lecture. So first of all, if you want to get data from the web, how does this work? So let's say the usual or traditional way is that you access, of course, everything on the web with your browser, which means there must be a web server somewhere, like the Apache web server here, which aggregates and generates and of course, delivers the HTML file that is then in the end represented in your browser. But the data, for example, which fills the HTML file or the HTML template, this usually comes from a database. But you cannot access directly that database. You always have this filter mechanism that you have a web server which generates some web page, and this HTML web page is generated with the help of some data which comes then from a database. So you are not able to access directly this database via a web interface. So usually not in your browser. But of course, you can make use of data from databases. So usually, general applications or websites and platforms, they provide so-called APIs. These are application programming interfaces, which are special programming interfaces which enable you to access directly their data. The point is, usually all of these interfaces, they are proprietary and therefore they might be different. Of course, let's say an interface which gives you access to the Google index might be completely different than the interface you use when you, for example, look for a book at Amazon or another bookstore. So therefore, there you don't have the possibility of an exchange, or let's say of a standardized way to access all these databases. You always have to comply to different APIs. And the problem there is, once you have written your application, probably the API provider somehow changes the interface. It means the database, of course, it grows, the schema might change, and therefore, of course, the API has to be changed. And then suddenly, your application is not able anymore to access exactly that database and that data via the old API. And you have somehow to update your API. So the point here again is, proprietary APIs make it difficult to access data, make it complex, and of course it's not persistent because this all might change. And if you want, for example, create mashups which use a multitude of data which is out there distributed in the web, of course you have to use several different APIs, and all of these APIs, they are different. And of course then the problem that you have multiplies. So if we look in the web today, the data is locked up in so-called small data islands, which are provided by several distributed databases which belong to certain kind of applications or service providers, data providers. And the problem is other applications usually cannot access exactly this data. So what you then have between all these information providers, there are huge walls that you have to climb to get to their data. So there is no, let's say, general path or way that you can access all of them, because the APIs are all different. Okay, I mean, we talked about semantic technology, and we all know that semantic technology is perfectly well suited for data integration purposes. But it's also well suited to form a standard application programming interface for the web. So if everybody or every database would publish its data in terms of RDF data, then of course it would be pretty easy to access this data with a standard API via HTTP. If this data is dereferenceable, you can use HTTP as an access mechanism, so you don't have to prevent somehow firewalls because you are using some strange port number which is reserved for specific applications, because this would be then presented on the web under the standard HTTP port 80. So this would be really nice. And on the other hand, of course, all this data could also be interlinked among each other which is of course not the case between these proprietary databases. So what we want to do is, of course, we want to publish data on the web, of course, with the help of semantic technologies. And this, in the end, is called linked data. And to publish your data as linked data, you have to follow 4 simple principles that we want to talk about. First thing of all, we know that use URIs if you name something. Then you should use HTTP as an access mechanism, and you should, of course, provide usable information behind that HTTP, best, of course, with the web standards like RDF or Sparkle. And then, of course, you should link your URIs and your data to other URIs, so they can discover more things. So these are the 4 basic principles. We will talk about them in a few minutes. But first, let me get to the term linked data, and of course then related to that, the web of data. Where does it come from? It's rather old, so at most 10 years now. So Tim Berners-Lee, you know him, he's one of the fathers of the semantic web and also one of the fathers of the World Wide Web. He coined that term, or this notion dates back to an idea from Tim Berners-Lee, where he sorted out some best practices for publication and linking of structured data on the web in this 2006 document that you can access here. So the basic assumption of data on the web usually is the value of this data increases when they are connected to other data sources, because they emphasize each other, they relate to each other, and therefore the value also increases. So therefore the web of data is nothing else than it's about data, of course, and a naming model that you use on the web. And into this we want to look deeper now. First principle, we all know that use URIs to name things. And of course you should not only name web documents with URIs, but everything you are talking about. So this means real objects, so arbitrary objects, abstract concepts, everything. And as you know, you find information or representatives of these objects that you are talking about on the web under lots of different URIs. We should not always use DBpedia. DBpedia is really nice, and of course it serves as a central hub within the web of data, but there are also other authority files, authority data sources which can be used. So here, for example, for Johann Wolfgang von Goethe, you can also use the so-called International Authority File Identifier, which is used by lots of libraries, for example, around the globe. So that's the SFIAF identifier. Or here for Kraftwerk, you can also use a URI which specifies this music group on a site called MusicBrainz. Or for movies here, it's an old science fiction movie, Metropolis. There the authoritative source is not necessarily DBpedia, but probably IMDb, the Internet Movie Database. And there you also have a URI for that. So if you want to talk about things, use URIs. Either use URIs that already exist or create URIs according to the design principles that we have already talked about. Okay, that's the first point. Second point, we also know that, of course, for the access, we use simple HTTP protocols. So we use HTTP URIs so that people can look up those names. And for lookup, you should have these dereferenceability issues, of course, considered, which means you should have a possibility that the URIs can be looked up by machines, and you get the machine interpretable representation, as well as when the content is looked up by humans, then of course a human readable content should be displayed. And we can do this, for example, via content negotiation, as we have learned, or for example, we can make these distinctions via hash URIs when talking about subjects and talking about information about these subjects. So we have covered this topic already, and we know how to do that. So we use these HTTP URIs so that people can look up these names. And then, of course, as soon as we provide information about this URI, then useful information should be provided by using the W3C standards for doing that, which means we use RDF for encoding information. And of course, Sparkle would be nice to have a query language and to access this data, for example, via a Sparkle endpoint. So point is, all of these URIs in the RDF graph should be made dereferenceable. They should be accessed, and if you access then the URI, then of course information about this URI should be somehow be accessible. One best practice principle there is that some of the already known RDF constructs should be avoided because they cause problems in terms of complexity. For example, think of reification or think of collections and containers. When you use Sparkle as an access means, then of course this is an additional step, or let's say it adds additional complexity to your Sparkle queries whenever you are using collections and containers. And this of course makes then your Sparkle queries and also applications which rely on these Sparkle queries less efficient, and therefore also, of course, you should avoid by using that. The same is for unnamed blank nodes. Sometimes blank nodes we have learned that they are interesting and are really a benefit to use, but of course you should make them somehow referenceable, I mean at least in the document you are using. So just take care about these 3 design issues. These are only best practices, so this is not mandatory. Okay, and number 4, we also know that whenever we put data on the web, we should somehow interlink this data. And then the user has the possibility to discover new data, new interesting things that are somehow related between my data and other data sources. So for producing these links, you have several certain types of links. There are, for example, so-called relationship links, which simply relate one URI to another URI, which relates these 2 entities in some sense. And then we have so-called identity links, which are usually used to denote that 2 entities are the same. So for example, via OWL same as, or for classes via OWL equivalent class. And then there are so-called vocabulary links, which usually refer to comments, or they refer to an explanation or a description of things, so to the definition of the original entities. So these are the 4 basic principles. And to consider them, or if you consider them, you end up in a web of data, which is nothing else but a huge set of data sets which are all interconnected with each other and who all follow these linked data principles. So for the last census, which was in August 2014, it was more than 1,000 data sets, which provided about 75 billion RTF triples with about 808 million links among them. So this is a huge amount of data that you can use here. And on top of that data, later on in the lectures, you will see how we can make some knowledge mining and knowledge discovery. Okay, so this is the web of data. The web of data has evolved, of course, with the emerging semantic web technology. And you see here, this was the starting point in about 2007. So only a few data sets were linked amongst each other. So here you see, for example, DBpedia, but also other data that we already know. We have talked about FOVE, this friend of a friend data, or just I have mentioned, for example, MusicBrainz, which is a huge knowledge base, or a huge website which provides data about artists and songs and music in general. So these were the very first data sets that were interlinked with each other. You see then by the end of the year, a few others came together. So for example, also OpenScig, which is another huge ontology which can be used, or which is used also for mapping concepts and entities within the data set. Then the next year, again, also very interesting, on the left side, you see that the first professional data was put also in the web of data. You see here the BBC play count data and the BBC program data. As I've already mentioned in the very first lecture of the course, the BBC was one of the first companies who adapted this linked data concept and then also provided data about their assets, about their entities within the web of data. So this is really an interesting thing, or an interesting development. And then you see it fosters further, it grows 2010, 2011, and then this is the state of 2014, December or August 2014. This was the last census and the last creation date of this huge linked data cloud, which of course is constantly growing. Okay, so Now consider you publish your linked open data. Of course, you want to follow all the principles. Sometimes it's not necessarily possible, but when you make your data publicly available under these linked open data principles, you should of course then make them public with, for example, this Creative Commons license, that everybody is able really to use that data. And on the way to that, so that you can keep track or can judge the quality and the state of the data, so there has been developed a 5-star criteria for linked open data. I will show you this right now. So your data will be granted 1 star whenever it's available on the web. The point is, just use an open license, Creative Commons CC for example, then it has already 1 star. So no matter whether it's linked data or not, if it's available, 1 star. 2 stars if it's machine-readable structured data, like for example, if it's Excel or something like that, instead of, as it's stated here, an image scan of a table. So Excel data, for example, is proprietary data, but nevertheless, if you are using the right API, you are able to read the data which is stored within Excel. Then you have 2 stars. The 3rd star is granted if for encoding your data, an open format, a non-proprietary format is used. So for example, if you use CSV instead of Excel, then everybody can read this data via an own API, because this is rather simple and everybody knows how it works. So then it's 3 data. Okay, 4 data, then all the above, plus, of course, you use the open standards from W3C, so you use RDF and Sparkle. URCs to identify things and stuff like that. And then, of course, people can point at your stuff and people can dereference your stuff. Then you have already 4 stars. And as you can imagine, the last one, the 5th star, that will be granted if, of course, you are linking to other people's data. So whenever we have these connections, so the most important thing in linked data, of course, are the links, then you will get 5 stars. Only this is full-fledged linked data. So these are the linked data principles and these 5-star criteria for linked open data. Whenever you want to publish, you should follow exactly these guidelines. So here you see it in a small infographic that you can see the difference between 1 star, 2 star, and so on. And you also will get information about that process and about this initiative on the link that is provided here on the right side. Okay, in the end, of course, we sum up with the advantages you will have with linked open data versus proprietary APIs. I mean, you should already know that, so it's only a summary of things we have already talked about. So first of all, if you're using linked data, you have a simple and you have a completely generic API for heterogeneous data sources, which enables simple reuse as well as data sharing. Whenever you are using an RDF data model, this guarantees simple extensibility. So changing a schema, a data schema, is no big issue if you are using RDF. We already know that. Then, of course, transport of the data, access via HTTP, standard port 80, so this prevents firewall adoption. And what is also a major benefit, your linked data most times is linked to classes and, of course, much more sophisticated knowledge representation within ontologies. And then this enables meaningful connections between your data sources. And, of course, based on these ontologies, whenever it's possible, you also can apply reasoning. So reasoning over linked data enables the generation of new knowledge. So, for example, we can inference from implicit to explicit knowledge. And these are, of course, the big advantages that linked open data provides against the standard traditional way and the proprietary APIs. Okay, so much for the linked data principles. In the next part of the lecture, we will make a short tour through the entire linked data cloud, that you see what kind of data we are dealing with.